Hi everyone, Assalamualaikum. In this video, we are going to discuss example 4 under area between curves. Okay, find the area bounded by the curve gx equals to x squared minus 1 and the line fx equals to x plus 1 as shown in the figure below. Right? To find the area, we can integrate with respect to x or we integrate with respect to y. Alright? When we integrate with respect to x, okay, we need to use top function minus bottom function. Okay, and from here, it is clear that the line here is the top function and the curve here is the bottom function. Okay, means that formula number 1 is suitable to find the area for this case. Alright. Right, this is the intersection point. Okay. So we need to find this value on x-axis. Right. Because to find the area of the shaded region here, we need to find lower limit here and upper limit here. Okay, we already given lower limit. But now we need to find lower limit, upper limit. Okay. Alright. Let's say we check when we use formula integration with respect to y. Okay. When we integrate with respect to y, we need to use limit on y-axis. And from here, we can see that when the intersection point, okay, we draw a line from the intersection point to y-axis, the line cross the shaded region. Means that it is not suitable to use second formula. Alright? So in this case, we use the first formula to find the area of the shaded region here. Right? So now we want to find this value, means the value of upper limit on x-axis here. Okay, so how to find this value? Okay. Alright, from here. And before that, if we use upper limit x equals to 1, we just find the area for the purple region only. Right? But now the question is finding the area for the region R. Okay, means the blue region here. So we need to use upper limit here. Okay, so now we need to find the value of upper limit. Okay. Alright, to find the lower and upper limit, okay, we already given lower limit actually. Okay, so from the intersection point here, okay, we can solve simultaneous equation, okay, between curve here and the line here, okay. Alright, and we can equate this because the curve gx and the line fx intersect at this point, okay. So we can equate x squared minus 1 here equals to x plus 1 here. Okay. Then we solve quadratic equation. So right hand side should be 0 and then we need to rearrange. The first term should be term containing x squared. The second term should be term containing x. And then the third term should be constant. And then from this quadratic equation, we can factorize. So we get x plus 1 times x minus 2 equals to 0. Okay. Then when we equate each factor to 0, so we get x equals to negative 1 and x equals to 2. Alright. So now our upper limit here, okay, x equals to 2. Okay, because we already given negative 1 here. X equals to negative 1 here means the lower limit here. Alright. Alright, we don't need to find the value of y because there is no question about intersection point. We just want to find the lower and upper limit. And then we use lower and upper limit on x exists here. That's why we just find the values of x. No need to find the value of y in this case. Okay, unless when we want to find the intersection point or when we integrate with respect to y. So we need to find the value of y. Right? In this case, we just find the values of x. Alright? Alright, after we find the lower limit and upper limit, okay, the values on x-axis, okay, then we can rewrite here, okay, to avoid mistake, okay, this is the line fx equals to x plus 1. This is top function, okay, and this is line gx, this is the curve gx equals to x squared minus 1, okay, and this is bottom, okay, bottom function. So from the shaded region here, it is clear that fx is the top function and gx is the bottom function for the shaded region only. Alright. Alright, then we can find the area of the shaded region here. Okay. In the previous slide, we discussed that you need to find the area using dx. Okay, so area equals to integration from lower limit x equals to -1 to upper limit x equals to +2. Okay, and then when we integrate with respect to x or when we use limit on x-axis, means we need to deduct from top and bottom here. Okay, alright, and then the function for top and bottom, we need to write in terms of variable x because now we integrate with respect to x. Okay, and from here, okay, x equals to -1 and x equals to 2. Okay, we use lower and upper limit on x-axis because we integrate with respect to x. So all term and involving all term and lower and upper limit must in terms of variable x. Right? Okay, so we use lower and upper limit here. Okay. And then area equals to integration from -1 to 2. We replace top function equals to x plus 1. And then minus, we replace bottom function equals to x squared minus 1. And after that, we expand and simplify. So we get area equals to integration from -1 to 2 to plus x minus x squared. Right? And then from here, we can integrate with respect to x. Okay? And when we integrate, no more integration sign after we integrate. Okay? So area equals to, we integrate 1 by 1. We integrate 2 equals to 2x. Plus, we integrate x with respect to x using power rule. So we get x squared over 2. And then minus, we integrate x squared using power rule. We get x cubed over 3. And then no plus c because this is definite integral. So we must write square bracket with lower limit and upper limit. Okay. After that, we substitute upper limit first into variable x. Okay. And then in between must minus sign. And after that, we replace lower limit -1 into variable x here. Okay. So we get this. Before that, negative here, negative, the power of odd equals to negative. Negative times negative equals to positive. Negative, the power of even equals to positive. That's why we get positive here and positive here. Alright. And then, after we simplify, so we get area equals to 9 over 2. And then we must write units squared. Squared here for area. Alright. And from here, we get area positive value because area always positive. Alright. If we get area equals to negative value, so maybe there is something wrong when we set up or when we integrate. or when we evaluate here. Okay, so the area must be positive. Alright, so the answer area equals to 9/2 units squared. Alright. Coming up next, more examples for area between curves. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.